Check it.
Okay, welcome back. Today we're going to be talking about square root functions. So square root functions are very closely related to square functions, also known as y equals x squared, also known as quadratics. So when we learned about square functions, y equals x squared, the parent function was the parabola that sits in the center like this. And if you wanted to move the parabola around, you would include a horizontal shift h and a vertical shift k. So this told you which way to move left and right, and this told you where to, how much to go up or down. And also there was an a over here, like for stretching it, wider and narrower, that sort of thing. Well, a square root function is the inverse of a parabola. Okay, it's the inverse of a square. Okay, square rooting is the opposite of squaring. So we learned that if you have a function and you reflect it across this dotted line, you get the inverse, and the inverse of that would be this. See, this is the inverse of this, and then for this part here, you had a different function, which was that. So basically, you have a sideways parabola. So we saw a little bit of that in the last section. Now let's just focus on square root functions. So let's not talk about parabolas right now, but that was like a nice little intro. So the square root function, its basic parent function, starts at the origin and looks like a sideways parabola, like that. That's your basic y equals square root of x function there. Now, if you want a negative version of this, the upside down one, y equals negative square root of x, that would be also starting at the origin but going the other way like that. Okay, and let's do this a little bit more neatly. When you put them together, okay, when you put together y equals plus and minus the square root of x, these two functions together make what look like a sideways parabola. Now, the reason why you need to have two separate functions for this is because together they fail the vertical line test. Okay, if you can hit something more than once going straight down, it's not a function. But if you look at each one individually, if you look at the blue one by itself, that passes the vertical line test because you only hit it once going down. And the red one also passes the vertical line test. But when you put them together as one function, then you fail the vertical line test. So you need to have two separate things here if this is going to work as a function. Okay, so let's just go back to the parent function. The parent function is this shape right here, and this is what we're going to start with. Now, what if you want to move it around? Well, like I said a minute ago, for a parabola, y equals x squared was the parent, and then if you wanted to move the parabola around, you would introduce a minus h for the horizontal shift, and a plus k for the vertical shift, and an a for the stretch. Well, for square roots, you also can do the same thing. An h will move you left and right, a k will move you up and down, and an a, if it's positive, will have you going up, if it's negative, will have you going down, and if it's bigger, it'll make it more steep, that sort of thing. So let's sketch. So actually, this is the wrong word here. Let's sketch this square root function here. Now, what I mean by sketch is we're not going to make a table. We're just going to find the starting point and draw a curve that hopefully is close. So the parent function is, like we said, this parent function right here. I'll draw it as a dotted line. That's your parent. Now this is telling you to go which way. This is 2 to the left. Remember, horizontal shifts are always the opposite sign of what they appear. And this is telling you to go 5 up. So take your origin center, go left 2, up 1, 2, 3, 4, 5, and now your function is over here, like that. However, there's also a what here? There's also a negative here. Your a is a -1, right? Which means you're not going up, you're going this way. You're the upside down version of that shape. And there you go. So there's the parent function as a red dotted line, and there's the actual sketch of this function. Now, to do this really right, you need to make a table and figure out what the points are on the way, but this was just a quick sketch, okay, of y equals negative square root of x plus 2 plus 5. Okay, so that's sketching this parent function, moving it around, flipping it. Quick intro. Now we're going to get into the real meat of things. We're going to be graphing these, not sketching these, graphing these for real using a table. We're going to be finding the domain and the range for these functions. So let's just jump right into it. Now here's the thing about square roots. You cannot square root a negative number without going into imaginary stuff. And we're not going to be talking about anything imaginary here because we're graphing. And graphing, what you see on a graph is only real. So if you look at this y equals square root of x plus 5, what kind of x's can you plug in here to make a table? Okay, because we can make a table. And, you know, we can do what we do with parabolas like -3, -2, -1, 0, 1, 2, 3, but that doesn't really work for this. Okay, we need to know where to start our table. So the question is, what numbers can you plug in for x? What numbers can you not plug in for x? Let's try -10, for instance. If you plug in a -10 here, this becomes y equals the square root of -10 plus 5, which is y equals the square root of -5. That's not possible. You can't square root a negative number. Okay, so that's not real. That would be an imaginary number, right? And we don't want that. We're not getting into irrational numbers here, or sorry, imaginary numbers here. So what numbers can you plug in here? Well, -10 didn't work. How about -9? No. -6. -6 plus 5 is still -1, which square root of -1 is imaginary, right? That would literally be y equals I. We don't want that. So how about 5? Can you start with 5? Well, yeah, 5. -5. -5 plus the 5 that's already here will give you a 0. Can you square root 0? Yes, you can. Square root of 0 is 0. So that means, hey, you can use -5. So there you go, -5, 0. And then from there, because this is a positive square root, you're expecting it to start, all right, at -5, 1. Also, this also means go to the left 5. So 1, 2, 3, 4, left 5. You're expecting something that looks like that. Okay? But we're not going to sketch it. We're going to really graph it. So we're going to take this right here and graph this point, which is also -5, 0, and it's right there. Okay? Now the question is, I just did a lot of guessing and checking until I finally hit it. You don't want to guess and check. So the way to do this is to follow the steps I have written up here. Okay, let's back up and start over. How do you graph a square root function? The first thing you want to do is find the domain. The domain is what x's work for this function, which is exactly what we were guessing and checking at a minute ago. But you don't have to guess and check. There's a strategy for this. Simply put, whatever's in the square root here cannot be negative. This thing right here that I'm highlighting in yellow is called the argument of the square root. The argument of the square root, okay, the radicand as it were, cannot be negative. It has to be positive, which means greater than 0, or it can be equal to 0. So you take this radicand, this argument here, and you set it greater than or equal to 0. That guarantees that whatever you get for x is going to make this either 0 or positive, not negative. So simply solve for x now. You take this, you set it greater than or equal to 0, you solve for x by subtracting 5 from both sides, and what you get is the domain of this function is all real numbers such that x is greater than or equal to -5. Okay, there you go. There's your domain. And that's your first point, finding the domain. Now, in the book, they don't necessarily use the all real numbers thing here, but it's implied. Okay. Now that you know what the domain is, that x can be equal to -5 or greater, that tells you what to do with your table. Now you know that you're supposed to start your table at -5. Okay? Now, the question is, how far do you need to draw your table? Well, now that you know you're starting at -5, what I advise is write enough numbers to get you to the end of your graph, whatever your graph is. So, -1, 0, 1, 2, 3, 4. Okay, well, here's the deal. We're going to save some time. We're not going to plug all of these into here because a lot of these are going to create decimals. And since we're trying to do this mostly without a calculator, what we're going to do is, this is not in the textbook, but this is how I suggest you do this, plug in the numbers, and if you get a whole number answer, write it down. If you don't get a whole number, skip it. And try to get 4 whole numbers over here, okay? Or at least things that aren't square roots, okay? Rational numbers. So let's see what we get here. We started with -5. You plug in a -5 here, you get 0. Square root of 0 is 0. We already knew that one. If you plug in a -4, -4 plus 5 is 1. The square root of 1 is still 1, so that's going to be a 1. You plug in a -3 here, you have now the square root of 2, because -3 plus 5 is 2, and when you square root 2, you get a decimal. So we're going to skip that one. We're not going to do the decimal here. How about -2? You put a -2 here, this becomes a 3. Square root of 3 is a decimal. We don't want to do that. How about -1? -1 plus 5 is 4. Square root of 4 is 2. That one's good. And you can see how many points do we have? We have 1, 2, 3 points so far. If we can get one more, then we're good. Okay, one more. So 0. Plug in a 0. 0 plus 5 is 5. Square root of 5 is a decimal. So skip it. 6. If you plug in a 1, you get 6. That's a decimal. 7. You plug in a 2, you get square root of 7, which is a decimal. No good. 8. No good. 9. 4. You plug in a 4. 4 plus 5 is 9. The square root of 9 is 3. There we go. So we have what are called, we have 4 lattice points. 4 points with whole number coordinates. They're called lattice. We talked about these earlier in the year. Lattice points. Okay? Points with whole number coordinates, no decimals. Okay? So, or no fractions. So let's graph those lattice points. The first one is -5 comma 0, which I have here. The next one is -4 comma 1. So -4 comma 1 will be right there. The next one is -1 comma 2, which would be right here. And the last one is 4 comma 3, which would be 1, 2, 3, 4 comma 1, 2, 3, be right there. And hopefully you can see that sideways half parabola shape that makes a square root function. And just take it and extend it to the edge of the graph. And there you go. That's the function y equals the square root of x plus 5. So we have the domain of the function, we have the table, we have the graph. The last thing we have to find is the range. Now, there's domain and there's range. Domain tells you where the x's start and which way they go. The range does the same thing for the y's. So the range will be all real numbers such that y is doing something. So look at the function here. On the x's, this thing starts at -5 and goes to the greater than side. That's why the domain is x is greater than or equal to -5. But on the y's, we're starting at 0. See, y is 0 here. So y is starting at 0 and it's going up from there, not down. So we say y is greater than 0, or because you can also be equal to 0, y is greater than or equal to 0. So there's your range, and you should do that after you have your graph. So let's just review here. You start off by finding your domain. How do you find your domain? You set this thing inside the square root greater than or equal to 0 and you solve. Take whatever number you get for the domain and make a table. Start with that number and make a table. And keep going until you hit 4 lattice points. Okay? If you go off the graph completely and you can only get 3, I guess you'll have to deal with 3. But try to get 4. And you can see I did that pretty easily here. And you don't have to do all the in-between numbers. Just do the whole number ones. Then do your graph, and then after you have your graph, look at your graph and say, well, what's the lowest or highest? Where's the starting y value? It's 0. And am I going up from there, greater than, or am I going down from there, less than? We're going up, so it's y is greater than or equal to, and the number here is 0 because we're on the x-axis, so 0. Okay, let's try another one. All right, so first thing we're going to do is find the domain. Now, here's what some people, a mistake that some students make. They take this whole thing here instead of greater than or equal to 0. The 2 that's on the outside here, this thing, this is not part of the square root. Do not include this in your domain calculation. Only the stuff inside, underneath the radical. This thing, okay? This is your, what's called your radicand, your argument of your square root. Take this thing only, okay, and find your domain with it. So, x minus 3 is the thing inside. Now notice I'm not using the negative here, I'm not using the 2 here. I'm just using the x minus 3. X minus 3, and what do you do with it? You set it greater than or equal to 0 to make sure that this thing is not negative, not less than 0. Now you solve. Well, this is really easy to solve. You just add 3 to both sides, right? So your domain is going to be x is greater than or equal to 3. Or, more specifically, all real numbers such that x is greater than or equal to 3. Now, you have your domain. Make your table. Where do you start your table? There's no guessing involved. You know you're going to start at 3. So 3, 4, 5, 6, 7, 8, 9. I think this graph only goes to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. So I can only go this far. So I might not get 4 good points. I might only get 3 good points, but that should be good enough. Okay, now let's start plugging in the x's up here into the function and finding our y's. You plug in a 3, this becomes 3 minus 3, which is 0. Square root of 0 is still 0, and negative 0 is still 0, so this just becomes plus 2, which is 2. Plug in a 4. 4 minus 3 is 1. Square root of that 1 is still 1. Negative in front of a 1 is negative 1. Negative 1 plus 2 is 1. Okay, so far I have 2 good lattice points here. 5. 5 minus 3 is 2. Square root of 2 is a decimal. I'm going to skip it. 6. 6 minus 3 is 3. Square root of 3 is a decimal. I'm going to skip it. 7. 7 minus 3 is 4. That's a perfect square. So you square root it. Square root of 4 is 2. This is going to be negative 2 plus 2, which is 0. So this becomes a 0 here. 8. 8 minus 3 is 5. You square root 5, you get a decimal, so skip it. And 9. 9 minus 3 is 6. That's a decimal, so skip it. So I only have 3 good lattice points here because that's all it's going to fit on my graph. Okay, we'll deal with it. So 3, 2. 1, 2, 3, up 1, 2. There's our starting point. Okay, that first point right there is your starting point. It determines your domain and your range. Okay, the direction now will also determine that. 4, 1. So 1, 2, 3, 4, 1. That's here. And then 7, 0. 7 is here. 0 is here. So you can see what you have here is an upside down square root function, the negative version of it. And we could kind of guess that because there was a negative here, right? So we knew it was going to go down. We also kind of knew it was going to go 3 to the right because there's a minus 3 here. So 1, 2, 3 to the right. We also knew that it was going to go up 2. So 3 to the right, up 2. We knew the starting point was going to be here, but we also wanted to find a domain and make a table anyway. Okay. So now that we have the domain, we have the table, we have the graph, the last thing to do is to find the range. Okay. And it's best to find the range once you're done. Now, the range is going to be all real numbers such that y is doing what? Well, the y is starting at 2, and from there it's going down. So y is everything that's less than 2 or equal to 2, less than or equal to 2. And you can see that the x coordinate of that first point is going to be the starting point of your domain. The y coordinate of that starting point is going to be the first point in your range. Okay, because your starting point is 3, 2. You're starting at 3 on the x, you're starting at 2 on the y, and then it's important to get the direction right. Okay, and there we go. Domain, graph, then range. In that order is my recommendation, the best way to go. You try to do the range before you do have the graph, and it's a lot more difficult. Okay, let's try one more and call it a day. So we're going to take what's in the square root here, this 2x minus 3 part here. Okay, the argument of the square root, the radicand. And what we're going to do is set it greater than or equal to 0 so we can find the domain. So set it greater than or equal to 0 and solve this. This will give you the beginning of your domain and the beginning of your table as well. So let's see, we'll subtract 3. We get 2x is greater than or equal to negative 3. We divide both sides by 2. And we get x is greater than or equal to negative 3/2. Now, we like fractions in Algebra 2, but because we're graphing, and only because we're graphing, I'm going to change this to a decimal, because when you go to graph things, decimals are a lot easier. So we're starting at negative 1.5, okay, which is right here. Your domain, by the way, is all real numbers such that our x is greater than or equal to negative 1.5. Okay, and if you're wondering how you draw this r, you can just draw a regular r and then just put a second line there to make it a double. Okay, let's keep going here. So now that we know that the domain starts at negative 1.5, your table will start at negative 1.5. And then you want to go from there as far as you can here. So negative 1.5, I like to go by whole numbers, okay, because I don't think you want to get into too many decimals here. So the next whole number after that would be -1, and then 0, and then 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, that's to the end of my graph. And hopefully I can get a couple of good lattice points out of that. Now, if I don't get enough lattice points, I can go ahead and do some decimals. But I'm going to see how many I can do to avoid that. So, -1.5 is the starting point. If you put a -1.5 in here, 2 times -1.5 is -3. -3 plus 3 is 0. So this whole thing becomes a 0 plus 2 is 2. So that's my starting point right there, -1.5, comma 2, right there. That's where this thing is going to start. Now from there, let's see which way it goes. Let's plug in -1. -1 here makes this a -2. -2 plus 3 is 1. Square root of 1 is still 1. Then you put that negative on it. It's -1 plus 2, which is 1. So I have 2 good lattice points here. Next one is -1, comma 1, which is here. Looks like it's going down. And that kind of makes sense because there's a negative here, right? Plug in a 0. Well, a 0 here makes the square root of 3. So let's square, that's going to be, it's not going to be a whole number. So let's get rid of that. Put in a 1. That's going to make 2 times 1 plus 3 is 5. That's not going to work. Put in a 2. That's going to be a 7. Put in a 3. That's going to be 6. Plus 3 is 9. Okay, there you go. So 2 times 3 is 6. Plus 3 is 9. Square root of 9 is 3. -3 plus 2 is -1. So let's see, that'd be 1, 2, 3, -1. Now you're down here. Okay, that's 3 good lattice points. Put in a 4. That's going to be 8. Plus 3 is 11. No good. Put in a 5. That's 10 plus 3 is 13. No good. 12 plus 3 is 15. Not square rootable. Put in a 7. That's 14 plus 3 is 17. 16 plus 3 is 19. 18 plus 21. Okay, so not all these are going to be decimal. I only got 3 good lattice points out of this. So if you really want to, if you really don't have enough points to get a good shape, you can just go ahead and do one of the decimals. Like for instance, let's just do 9 here, the last one, so I know where to end this thing. So plug in 9. 2 times 9 is 18, and 18 plus 3 is 21. And now you want the square root of 21, which is definitely a decimal, right? So square root of 21, okay. And well, 4.58, and then stick a negative on that, and then plus 2. And see, I try to avoid decimals so we don't have to keep reaching for a calculator here. -2.58, we'll go to 2 decimal places. -2.6, right about there. Okay, roughly half. And now hopefully you can see your graph where it should be. So there's your graph. Now what's your range? Well, your range looks like this is a 2 right here, right? Your y's are starting at 2 and going down, so your range is all real numbers such that y is less than or equal to 2, meaning it starts at 2, but it goes down from there. And there's your range. So we have our domain, which we get from the inside of the square root, set greater than or equal to 0. You write your domain first. You make your table starting with the domain. You do the points that you can do, hopefully without a calculator, just, getting whole numbers. And use those to graph. If there aren't enough of them for some reason, like in this case we only had 3 of them and we could use an extra one, then go ahead and plug in one of the other ones and go ahead and do it with decimal. It's just more, it's less work if you have to, if you can avoid the decimals. All right, we're done. See you at the next video.
Check this.